Question number 34. A company produces packs of pencils and pens. So we do have two variables, pens and pencils. Let's go ahead and then call pens X, since we're just reading Y. Now these are the information that are given. It says the company produces at least 100 packs of pens each day, but no more than 240. So if I have to write an equation for this, remember pen is Y, so I'm gonna go ahead and then put this one as how many pens? Well, Y has to be at least, means it could be what? 100, but no more than 240, so it actually can be what? 240 pencil. So less than or equals. Perfect. The company produces 70 packs of pencils, and pencils are X, but it says produce at least, so it could equals to 70, but it says no more than 170, so this is going to be no more than 170. All right, now it says the total of less than 300 packs, so this one is less than, so there's no equal sign. 300 packs of pens and pencils are produced. So when we remember X and Y are number of pencils, I should actually write number right here, it would help a little bit. So if I combine the number of pencils and pens, they cannot be more than 300. Remember, this is less than, so we cannot have the equal sign. Now we know that each pack of pens costs about $1.25, and then each pack of pencils costs 75 cents. So if we're looking for profit, it says what is the maximum profit. So let's call the profit function P. Okay, and we want P to be what? Max. That's very important. Maximum. So P is given by, so we're selling X amount of what? Pencils, and then each of them costs 0.75, so we're gonna multiply 0.75 by the total number of pencils that we are selling, and then we're gonna add this with what? The total number of pens that we're selling for $1.25. So we're selling $1.25, and there are Y numbers of pens that we are selling. So we want to make this thing the most, but the catch here is we have certain constraints. So we can do linear programming by drawing a couple of graphs and then looking at the place where they intersect and plugging each of those intersections, and the one that gives us maximum profit will be the right combination. So, but in order to instead of doing that based on this constraint, let's try a trial and error here. That might be the quicker method. See, if we want to make the maximum profit, we want to sell more pens and pencils because we get $1.25 from each pack of pencils. Now the thing is, the maximum amount of pens that we can sell is 240 pens. We can sell 240 pens, but if we sell 240 pens, then this leaves me with the number of pencils to be less than 60, because when we add them, we always have to add up to what? 300, less than 300. So if we sell 240, then we have to sell what? 60. But it says something about the pencils. It says the least amount of pencils that we can sell is 70. So we cannot sell 60, rather we have to sell 70. So if we have to sell 70, then this leaves us with 230. The maximum number of pens that I can sell is 230. That's for Y, and then the pen is 70, and then this has to be 300. Now there's one thing that we have to understand. If we sell 230 pens and then 70 pencils, that adds up to 300. So we cannot really sell 230 and then 70 pencils. So we have to sell one less than this one, and to maximize profit, we want to sell as much as what? 230 pens, but we're gonna make it 69. Now this would give us less than 300, but we have a problem. Again, we went below the allowed limit, which is 70. So this leaves me with the last option, which is to sell 229 pens and then 70 pencils, and then this would give us 299, which is actually less than 300. So X has to be 229 and Y has to be, so profit is equals to 0.75 X plus 1.25 Y. So based on this one, we have 0.75 times the number of pencils that we can sell is actually 70 plus 1.25 times the number of pens that we can sell is 229, and then this is 70. So when we do the maths here, this will give us 0.75 times 70 is gonna come out as 52.5 plus 1.25 times 229 is gonna be 286.25. So when we combine these two plus 52.5, we end up with $338.75. This is the maximum profit that we can make from selling these two things based on the given constraints. And then this completes the problem. Based on this, the correct answer would be choice choice A. Just to go over the other method, which is a more practical method by drawing linear inequalities. So if I draw a graph, something like this one, we have the x-axis here. This is for the pencil, and then we have the y-axis. This is for the pen and pencils. We do have a little grid here. I'm gonna go ahead and then put this one up here, and let me put this one up here and look at it. Since we have between 40 70, so we're gonna go by 50, 1 2 3 4 5, and then this is up to 300. So we have 300, so 50, 100, 120, 300. We got 1 2 3 4 5 6. So we got 50, this is 100, we got 150, 200, 250, 300. And then the same thing with this one. Let's go ahead and 50. Oh, this is actually 100, and then this is 200, and then this is 300. So we know that x plus y is equals to 300. So the y and x intersect will be right here. We can draw a little dotted line because they can actually equals to 300. That's the first one. Now let's go ahead and then change the color here, and then do the two constraints. The number of pens have to be between what? It says the least amount, the maximum that you can sell is 230, which is this 250. 230 would be right here. So could sell this many amount, and then the least amount that we have to sell is based on the choice. It says that it has to be 100. It's actually 240 and then 100. So that would be 1 2 3 4 5, which is right here. And then the next thing is you do the same thing with the other one, which is 70. That's 50. 70 would be right here. I'm going to change the color into greenish, and then you can see this one. This one has to be right here, and then it cannot be more than, says between 170. So I'm going to go ahead and then do 170, which is 150, 170 right here. Okay, so based on this, we